Hey, hey, Wages World, what is happening? What is crack-a-lackin', Kool-Aid Krew? Guys, we got some pretty big solar weather happening here. This is something I seen about a couple hours ago and been trying to put this together. Been debating on whether or not to start this right now. But as you guys can see, you're looking at the Soho Observatory. That is a massive CME eruption. Somebody give me a 5 for 5, and I'm just, seriously, I'm just going to keep on moving here. But if I don't have a 5 for 5, I'll look over there here in a second. But guys, yeah, we are about, you're looking at the Soho
Hold on.
Observatory. That is a massive CME eruption. Somebody give me a 5 for 5, and I'm just, seriously. There we go. Sorry about that, guys. Did that yesterday, too. What a rookie. You'd think with almost 61,000 subscribers, I wouldn't do that kind of stuff anymore. But, technical end of it, I'm a one-man show here, guys, so I apologize. Anyway, so we got this big, humongous, and it is a humongous eruption. I'm sorry, I'm just going to call it what it is. It is a fast mover. It is very, very dense, the CME that's related with this flare. And this is the same sunspot I've been telling you guys for 3 or 4 days. We're going to have to watch it. Now, I will say this. Now, I'm going to switch over here to the SDO satellite. And the SDO satellite, guys, is the one that's in geosynchronistic orbit. Matter of fact, before I go into a long diatribe about what the heck and where the heck that thing is at, how about I just show it to you real quick? Because I do this every time, and I waste everybody's time trying to explain it with words when I can just show it to you. Yeah. So here's the satellite that we're going to be looking at. And this satellite rotates like this to keep its eye on the sun, right there, okay? But it stays over this same part of our planet at all times because it orbits us at 15 degrees an hour, which is the same exact speed that we rotate around our axis. They do this for a lot of reasons. One of the main reasons is they can relay the data back to White Sands in almost real time. So we get a very quick return from our data collection. There's a lot of other satellites, the further out you get, the longer it takes, guys. This isn't like light beams getting transferred through whatever. We got radio waves and all that, so, yeah, we're not going to get into that. But that is how this satellite works, so we're going to, yeah. There is NASA's model of this CME. Now, as you guys can tell, and I was getting ready to say that here in just a second, it is not a direct hit from the CME. Now, yes, it is a direct hit from the flare, and I'll explain why here in just a second. Anything on the front disc, okay, if it's fully on the front disc, we get all of the X-ray that we could possibly get from it, okay? Light, when it gets exploded out, X-ray is light, okay? It goes out in all directions equally, unless it's being acted upon by other things, okay? And so with that being said, there is your X-flare. Now, this is a long duration one also. So with it being an X4.5 flare and long duration, there was no chance that this thing wasn't going to produce some sort of a decent sized CME. Now, we've had four, X-class, like a 4.5 X-class flare that was very impulsive and didn't produce much of a CME. But because this was more of a long duration event, this is what we get. Okay? So I'll play this in just a second, but I do want to show you guys NOAA first. Okay? So yeah, whenever you come over here and you see something up that high, you immediately stop and you look. So that is very, very close. I don't want to say very close. It wouldn't have had to go too much further, and we would have been seeing R4 radio blackouts, which we have not experienced in a very long time. Okay, so yeah. Now, I got a comment yesterday saying something about, hey, all this stuff, all anybody's going to feel is sunshine. What? Really? Like saying this stuff doesn't do anything. We'll never know it. Well, I would, and I left a comment. I've been leaving comments over there replying to people that say stuff like that, and I do it respectfully because I'm trying to be respectful. Even though I'm not the one taking the shot, you know what I mean? They're taking a shot at me. saying that this stuff doesn't really matter, but it does. So what I did is I told them it's exactly how I feel about it. Yeah, I told them, well, you might want to go ask the people that experienced the clear uptick in seismic activity, which happened, okay, plus all the extreme aurora we were seeing. I was showing in the comment underneath that video. I showed massive, crazy aurora from that. It amazes me, right? And then I said, well, if you have any doubt, and I said, try to look at this with a little bit of an open mind, whether you're leaning towards mainstream or alternative. Nobody argues the fact that this stuff affects us. Okay? The argument comes in wherever it's coming from, how it's getting here, how much is it affecting us, right? So, but we do know that this affects us. Nobody can argue that. That's a simple fact. So, I pointed them over to this. This is what the official NOAA Space Weather Prediction Center, this is their official stance on what would happen during geomagnetic storms, radio blackouts, and radiation storms. 3 different forms of space weather. So, yeah, I get a little fired up sometimes, guys, because it gets a little old hearing that same kind of whatever. If you're going to leave a little comment, do like a little drive-by, like a true troll like that, I mean, at least have the balls or the kahunas, whatever you want to say, to come back and answer my reply. And if that doesn't work for you, how about I just send you a Zoom link? We can go live together. I'll sit here and listen to everything you got to say, and I won't say a word. And then we'll decide who's right and who's wrong. So, anyway, moving on. Sorry. So, let's talk about this flare now. Yeah. So, guys, this thing is big, okay? Like I said, guys, where's it at? Here's the NASA model of it. Number one, it's very, very wide. It is moving faster than what we would typically see from a normal type of eruption from the sun. And so that is what it is. And because it's moving faster and it is denser, we can tell. Just from visually seeing it on SDO over here, we can tell that it has more density than a typical, just kind of the run-of-the-mill CME would. And I'll show you why. So I'm going to run this. I don't know why I ain't running it already. Got a little worked up there. Got to get myself back to center here. But, guys, again, look at that thing. And I don't want you guys, everybody's focused over here, right? Look what happens after it. Look over here. Wham. Okay, so that actually happened before this. So we can't be distracted just by looking at one spot on the sun. We got to look at the whole thing. That was big too. As a matter of fact, this might be why we might be seeing a radiation uptick, because this is in that danger zone area of the sun. That could have crossed our interplanetary magnetic field line when that one erupted. I don't know. I can't say for sure, but that's exactly the position you would be looking at over here for that. And that happened before this X-flare. So that is a massive eruption. Okay. Now, again, I'm not saying grid down nothing, because this is not grid down, number one. And that's the other thing, too, I said in a comment over there. If I was to ever say anything like that, I wouldn't have to even tell people, because they would already know, because we couldn't talk to each other anymore during a big event like that. So, well, I mean, do you expect it to be like that every time? That's a little bit ridiculous, in my opinion. Yeah, we expect this is on a cycle, guys. It will at some point, be like that. Hey, Juby Joe, thank you. Thank you for the membership. I really do appreciate that. Awesome. Awesome, awesome. Let me get you highlighted there. And thank you for putting a little bit of positivity back up in there. I got a little negative there, guys. I'm sorry. It just, guys, like I said before, I'm human, I can only take so much of that before I have to respond. And I did it in a respectful way, and I'm still being respectful. I'm not, it's okay for people to have those opinions, But don't get your feelings hurt or you get your butt hurt when I respond to it in a respectful way. Because I would imagine that's what's going to happen. I haven't went over and looked at it since that comment was made after I posted that reply. I almost pinned it, but that would be drawing attention to the negativity, and I don't do that. So I almost even deleted it after I responded so they could see it, nobody else could. I do that a lot, guys. So remember that if whoever's out there wants to leave a really nasty comment towards any other channel or me, I'll respond to you, and then I delete the comment because you will still see the reply and nobody else will see your comment. No drama. Save the drama for your mama. Back in the what, 90s or 2000s we had Obama, right? Ain't that how it works? I'm just kidding. I was just trying to rhyme something there. Anywho, anyhow, anyway. But yeah, I would just tell everybody, please stay away from the cats and the dogs at the apartment complexes. You know, I think I would rather eat peanut butter or cheese, just so you know. Anyway, that might be a little too far in this conversation, so I'm going to stop with that. That's going to go a little crazy there. I only said that because that's all over social media. It's crazy. It is so crazy, man. I laugh at it. I have fun with it. Anyway, so here is Soho, right? This is a real disc on the imager itself. So when we see energy popping around, we call it a halo. And when we see a halo eruption, that means it's either coming at us or going right off the back. We just have to know that, right? So how do we tell? Well, we look at our other satellite. Okay, we used to be able to do this. Come down here to stereo A. Okay, because this is a different satellite than Soho. But we no longer can because this is basically, well, it's a, we don't have a side view anymore. This satellite used to actually be way out here on the side. And it's no longer hanging out there. It's actually hanging out close to us now. It has outlived its lifespan. I don't think they're going to send this one back out. They might. I don't know what their plans are for this thing. I can tell you this. We typically only get like 6 to 10 hours of data from it now because they're not concentrating on it. Seeds isn't anyway, this website. Stereo A is still relaying its data back down all the time. It's just some of the websites have quit focusing on it because it has outlived its lifespan. Now, if we waited 3 days, we can actually get high definition imaging from this satellite. And I've shown that to you guys before, and we did, which would kind of look like this, right? It would look more like this, I would say. But as you guys can tell, guys, anybody's been following solar eruptions or any kind of space weather for any length of time, you know just by looking at this how fast this thing is moving visually. Okay, and I've done this for you guys before. This is the surface of the sun, this circle right here. Okay, so we got about an hour typically from a typical eruption. Hey Dennis, thank you for the gifted 5 memberships. There we go. How you doing, man? Thanks, buddy. I appreciate you. Hey, Full Hope, good to see you. All right. Thank you for that, Dennis. Awesome. Appreciate it. Appreciate it. All right. So, now, guys, again, we get about an hour from the surface to the edge of this occulter disk, right? So, and then you see the first moments of that. So that's at 15:36. That's 12 minutes later. That's 24 minutes later. That right there, whatever. We're about at an hour right there. And the leading edge of that's already off the screen. So what that tells me is just kind of a rule of thumb. Yeah, that's a fast mover. Okay? So if I push start, you're going to see the density of it here too. So I'll stop it right here and I'll show you what I mean here in a second. I'll back that up a little bit. On these coronagraphs and on most of the imaging I show you guys, the hotter material is going to light up like this. Okay, so it shows you the more hot material it's in one spot, the brighter it's going to be. So yeah, that's rocking it pretty good there. Okay, so not only is this a high speed eruption, This is high dense. Now I'm going to show you over here on SDO the 304, because the 304 actually will show you and prove to you guys how fast this thing is actually moving, because there's like this big ball of plasma that is like, wow, just crazy wow. But yeah. That's awesome, isn't it? Oh, man. Hey, Raven, good to see you. Thanks for using that wrench. Awesome. Love it. Anyway, he proving nothing, huh? Man, you know, here's the thing. You know, what do people think we have billions of dollars in our back pocket and we can have our own satellites up there to look at? Our own personal satellites? Or do I have to be standing on the sun and take a freaking Polaroid and shake it like... You know what I mean? I mean, come on. Cut me a break, people. Let's go here. Wow. Anyway. Come on and shake it. Shake it like a Polaroid picture. Anyway. So, yeah. Let's check this out on the 304. Ionized helium. Right? Now, this is extreme ultraviolet. So, what we're going to be able to see here is basically how fast and how dense it is. Because you're going to see a ball of plasma. I was actually kind of taken aback when I seen that kind of flight. It's not very big, but it's going to be... I'll show you what I'm talking about here in a minute. I'm trying to get there. I don't want to go too far. Okay, so I'll back it up. It's moving so fast, 1 to 2 frames, it's off. Okay, I'm serious about that. So we're at 1508. There's the first image that this one sees it at, and that's 10 minutes, right? Oh, was he? Yeah, whatever. Yeah, yeah. That's okay. I just don't like, yeah, it's all negative, but it is what it is. Yeah, I get you. Yeah. So I'll just, yeah, I'll stop there. You guys are doing a wonderful job in there. I'm serious. You guys do a great job. Love my mods. Okay, anyway, so that's 10 minutes, and then look, kabam, right? That's plasma. This is a light artifact, okay? This is an anomaly on the camera because the camera's having a problem understanding what kind of image it's looking at, right? So that's 10 minutes later, and then that's gone. Look at that. Okay, so we're talking 20 minutes from surface to the edge, gone, out of the image. That is fast. Okay? Not to mention that it's still got a curved look right here, which means it's probably still kind of trying to straighten out, and that usually happens here. This is a good one, guys. It really truly is. So let me go forward here a little bit. And again, let's see if that one shows up on... Yeah, it did. Okay, so I'm going to take your attention away from the X-flare for a minute. Come over here. Okay, this happened before the X-flare. Watch this massive eruption over here as far as, like, how wide it is. Okay, it's actually erupting like that big. It's a big one. And then look at all the solar rain. That's highly charged particles rushing back down to the surface of the sun on a magnetic connection line. Look at that. It just amazes me, this stuff does. After that eruption, watch that big looping arc rise up right there. Now, we've also got eruptions here and here. These things are, guys, we're going to have small ones in between. This one is going to hit us. It's not going to be a direct blow. If it was, we'd be having a little bit of a different conversation. It still, in my opinion, would not be like some sort of grid down or anything, but it definitely would be affecting us more. If this happens, you know, in 2 days, and it very well could again, it could even erupt bigger. I showed you guys this yesterday and was showing you the complexity of this sunspot, and I'm going to do it again here in a minute. But in 2 days, it's going to be about right here. So that means it's into your strike zone at that point, and any and everything that thing blows off is going to come at us. So, yeah, we got to be, this might just be the beginning of the story. I don't know. I can't predict the future. That was the other thing in that comment. I nowcast, and I tell people that day after day after day. I'm not forecasting. I try to give you guys my opinion 3 or 4 hours, maybe 6 or 7 at the most ahead of time. That's it. I nowcast. I come on here and show you what's been happening. And I try to explain so everybody can understand. I don't have the ability to forecast like a lot of other people can. That's way above my pay grade. And, it's not that I could never be taught. And I am getting better at it. But, I'm not going to come over here and claim that I can do that when I can't. You'll find other people that will do that. And you're not going to get that here. So, yeah. I tell you what we'll do here. I do want to show you guys the updated magnetogram, the colorized version where we can see the polarity of that sunspot over here. And the reason why is because see how complex it is? Okay? And what I mean by that, I'm going to pause it right there. If you look at the other sunspots, you have a clear distance between negative and positive, positive and negative, reds and blues. Look what's happening here. These things are swirling around each other. So when it flares is when we have that reconnection. When does it have a reconnection event? Well, when these two connect. Okay, so if they're closer together, they have a better chance of connecting. Right? It's like being on a date, either sitting on the same side of a booth or sitting across from one another. Which one do you have a better chance of stealing a kiss from somebody? You know what I'm saying? I mean, that's just an analogy, but that's what that is. And for all you young people out there, if anybody's listening to me, take somebody out. Don't DoorDash. Just kidding. I'm having fun today, guys. I'm sorry. I don't know why, but I am. So, yeah. Anyway. Let's, That's right. That's right, Hope. For sure. Love the name, by the way. Love the name. I seen you over on, you're on Marfugo a lot. There's full of Hope. See? Hope, 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 hope. Love it. Love it, love it. Okay, anyway, so watch this right here. I'm just going to run this again so you guys can see what I'm talking about. They'll start swirling around each other. So when they start intermixing like that, that's what it's becoming more and more complex. So when it does that, I mean, watch the blue kind of shoot in between two reds right here. If you can see that. If you're on your phone, you might have an issue. Hold on a minute. That's probably better to be able to show you. Okay? Right there. You see how it's kind of sneaking through? So, yeah. Now, again, remember, see the northern hemisphere? The polarity's different. It's the exact opposite as it is down here in the southern. So when we have our pole flip on the sun, next sun cycle, this will actually be reversed of that. So, just wanted to point that out. But yeah. Mods are busy in there today. I'm loving it. I love it. Love it, love it, love it. Anyway. My mods are awesome. And every mod in this community is awesome. I talked about that at length yesterday. Okay, guys, now listen. Also, before I go over that, we still have geomagnetic storming hitting us now. Okay? Everything is quieted down at this very moment. But we were at a G2, G3, almost a G4. We were at a G4 for 30 minutes back here on the 12th. Our magnetosphere is still getting rocked. Okay? It's going to take some time for it to kind of calm back down. But at the end of the day, it may not have enough time. Because we have so many smaller eruptions and decent sized ones. Now, if you guys have been watching me for any length of time, or if you know this model, you're going to understand real quick that this is very, very active. Okay, so I'm going to just, I'll play it here. But what I will do here, hey, Deepquake, thank you again. Awesome, man. Man, you guys just come through. I'll tell you. I mean, you guys are just like, wow. But yeah, so at the top of this, guys, I told you guys I needed two more subscribers to get to 61,000. I love it. And I love it. I love it. You guys are here for that, and it really is. It's cool. My goal is to get to like 65 by the end of the month. That's like 2 weeks. That's a pretty hefty goal. I would love to be at 100K by the end of the year, but that's kind of overreaching, I think. But ain't nothing wrong with having a goal, I guess. But anyway, this is the velocity, and the only reason why I say that, I want everybody to hear what I got to say, right? And that's what it's always been about here. And that's a good indicator if people are listening and watching, is if that stuff is moving in the positive direction. So yeah, I used to get like people used to take shots at all of us out here doing YouTube when we would change words so the algorithm wouldn't like hit, like penalize our video or something. And now everybody does it because they realize that, hey, if you want to use your voice, sometimes you got to change your voice. And that's exactly what I did, and it worked out. I mean, I don't change what I'm saying. I just change the actual words so it doesn't get picked up. You know what I mean? We don't have to use those normal words, And yeah, sometimes it does sound like we're talking in code. But, we typically will explain what we're talking about so people understand it. But anyway, this is velocity. You can tell how everything's just kind of active. Sun's off to the left. And this is just velocity. This is just how fast the particles are moving. Okay? If we want to see density, we come down here. And a lot of times we'll see a lot more with this. Now, it's going to be interesting to see when this one hits. Okay? The CME from this X-flare. Because it is, guys, keep in mind, it is not going to be a direct hit. So I don't want anybody thinking that this is going to be some sort of, like massive G5 storm. At this point, I can't say one way or the other. But if I was forced to give you guys my opinion on this one, this would not cause a G5 storm because you can tell this is just barely clipping us. The only way that could happen is if the CMEs that are hitting before this one cause us to be in such a geomagnetic unrest until this one gets here. This could push it over the edge, and we could get a little higher than what we normally would. Okay? So just keep that in mind. Again, 2 days later, we're right here in the middle of this thing. Okay? So I have to point that out. And that's, and again, I've been telling you guys that for probably 4 days now? Maybe even 5. Because that thing was erupting on the backside, if you remember. It had an X-flare on the backside that we didn't catch all the X-ray from. Because the sun actually occulted part of it. Blocked part of it from getting here. So, yeah. Now, again, guys, here's the density. And, and like I said, we got pretty much quiet conditions right now. Now, I'm saying we have quiet conditions, but do you see all this red magnetic pressure? Why is that still here? Because we're still trying to get back to our ambient conditions. This is what I mean. Our magnetic field is not back to normal yet. So if we get hit again, it won't take as much to send us into geomagnetic storms because we've already got geomagnetic activity hanging around. And it does take a little bit of that anyway. And like I've told you guys before, I guess if you wanted to pick a number over here on the KP to be perfect to where we stay at, I would say 3. Anywhere between 2 and 3. Okay, because if we get much lower than that, and we stay low like that, then we become susceptible to cosmic rays. If we get higher than that, then what are we looking at? Geomagnetic storms. So it takes a balance from the sun. And, I hear a lot of people say, I don't want to get hit with no geomagnetic storms. Yes, you do. Yes, you do. You just don't know it yet. So, yeah. And like I said, probably, I don't say it as often as I used to, but the sun helps protect us from the sun. And I know it's odd, but that's just the truth of it. Okay? Now, just like we have this, magnetosphere, we have something called the heliosphere. Okay, what that is, that's the sun's magnetosphere. So yeah, so the sun stretches out like that too for our whole solar system, and it blocks everything, or helps block things from coming into our inner solar system to affect us. And I oftentimes have to remind people too that, hey, we're not just talking about on a horizontal plane here, guys. Space weather can come from underneath, from the north, from the back. When we're talking about cosmic rays, they can come from anywhere. So, yeah, I'll just leave that at that. I don't usually go that kind of in depth there, but also, they are expecting another CME to hit. It is overdue. So what that means is typically if something's overdue, it means it's moving slower, and it wouldn't have the effect that it would have if it would have hit on time, because it would have been moving faster. Okay, but if it's dense and our magnetic field is still getting rocked, it's probably not going to matter a whole lot if it's only slowed down a little bit. Now, this is Dr. Tony Phillips over here at spaceweather.com. Please come check him out. Hey, give me a roll call in there if you guys would. Hey, guys, I'm not sure if you guys knew this or not, but I seen a lot of reports yesterday of people commenting on what the moon looked like right at dusk, because I even commented on it, because I had my wife and my daughter come into the window and look at it. It was just really, really hazy. You know, we had a lot of humidity hanging around, but it was like excessively hazy. And I think it was just because the time of day and where the sun was at the same time. But I thought it was interesting, because I started hearing other people across the country talking about it. And also, I do want to touch on this, okay? This is not Aurora. This is something called a SAR arc, okay? It's basically a heated part of our ring, okay? Yes, the Earth has rings. I'm not sure if you guys knew that or not. They're not made up of ice crystals like the ones on Saturn, but we do have rings. So sometimes when we get hit with these solar storms, the ring current here will leak. And it'll leak down into our atmosphere, hence heating it up. And because it's on a ring, it looks like a straight line going across the sky. Okay? So that's what's happening there. You can see the green colors here too. So, and it's I think it's happening right in the middle of Aurora also. So, you know, a lot of times that's what you see, because it takes a geomagnetic storm to kind of cause this. And what causes Aurora? Geomagnetic activity. So most of the time, you know, it is what it is. So, you know, we have Aurora, we have Steve, and I'm not going to go into what that is, but that typically shows up. Steve is usually like vertical almost, okay, but it's a vertical red line. Then you have air glow, which is basically superheated air, okay. I'm not going to go into a whole explanation, but we're talking about SAR arcs, SAR arcs. They actually discovered these things back in 1956. And I knew all this, but I'm glad he wrote this article. So please come over here and read this over here at spaceweather.com, because we're going to see some awesome aurora from this thing. I'm telling you guys, I can't wait. Cannot wait. But it just is what it is. Rick, that was pretty funny, brother. So, you know, I'm laughing at that one. That's a good one. Anyway, let's what was I? Oh, okay. Yeah, I did want to show you guys this. Give me 1 second, guys. I need to switch you guys over to a different screen just for a hot minute. I need to bring something in. I thought I had it up here already, but I didn't. Okay. I'll bring you back in right about now. Okay. So, guys, what are we looking at here? I showed you guys this yesterday, but I'm going to show it to you again. And the reason why, it's awesome. This is Gary Mustard II, Evolution's photography. He's Evolution Studios on YouTube. Go check him out. But check this out. This is unfiltered Aurora from the other day. And what we're going to look at, because the Aurora was moving west to east. And typically we see it moving east to west. So, and this is from northeast Colorado, about 3:30 in the morning. And what you're seeing there, I mean, it's just freaking awesome, number one. And I would assume because he's in Colorado, he's at a higher elevation. But we also had a shooting star shoot across there. So I thought that was pretty cool. So I'll keep playing this for a second. But I just want to point out, guys, you know, you see how it's moving that direction? Now, I say it's moving that direction, but it could actually be just an optical thing. Because when we're talking about Aurora, we're talking about excited particles trying to get back to their stable state, okay? And sometimes they can give us some sort of just a optical effect that fools our eyes. And that could be what we're seeing here, but I don't think so. I'm not saying that the charged particles that hit us is coming from a different direction. You have to understand that we're sitting in the middle of a donut when we're talking about our magnetic field. Our magnetic field lines are like a donut around us. So if you take it like north to south, you loop it out all the way around our whole planet. Okay? So with that being said, depending on which, you know, what we're seeing here, those particles can move in different directions. They don't have to always move the same direction. It's not air. Okay? When we're talking about like upper air currents steering a hurricane and things like that, this is different. Just like solar wind is not wind blowing through your hair. You can't get in your Maserati, put the top down and go cruising on the sun. You can't do that. Okay? It's not air. And that's what I try to tell people. And it is a very valid thing to kind of think that, because we call it wind. And for all of us, our whole lives, what's wind? Yeah, it is that stuff that blows our hair back, right? But this is not that. So, I'll show it to you again here. So where are we all from? Did I miss the roll call again? I probably did. Hey, Johnson Earl, good to see you. Yeah, Ivy, that's a good point, Ivy Randall Gooch. Since May, we have had a solar storm once a week. Before, they were 20 years apart. They weren't 20 years apart, but they were, yes, we're in solar maximum, and this is kind of what we would expect during solar maximum. It's not something that we didn't expect. I just want to make sure everybody understands that. Colorado, what's up, Gentwitty? Georgia, that's right, baby. Northwest Georgia, Hilly, that's right. St. Louis, Dennis. Orlando, Florida, Camp Krusty, Maine. There you go, Camp Krusty. Is that true? Is that just a gunslinger? You kill me, man. I love it when you're here. Oh, my goodness. Chattanooga, baby, no mandates. That's right. Hey, Star, good to see you. What's up from Morgan? Karen Myers, Northwest Ohio, baby. All right. Yep. Full of hope. She's across the pond, guys. Just so you guys know. Y'all should know that. She's here. She's a staple here in our community here. Always say, hey, Ripper, good to see you, bud. Good to see you, man. Didn't realize you were even in here. Hey, Stephanie, I got your email. I replied to you. Hopefully you've seen that. Southern Oregon, baby. Southern Oregon. We know where Kathy's from. I'll give you guys one clue. Aloha. Or spam. Or what else can we say? Rip, you know that's where your family's from, right? Am I correct on that? Yeah, you told everybody that. Eating the spam. Hey, Kathy, how much is a gallon of milk over there right now? I know it's got to be outrageously high. I mean, back when I was paying $2 a gallon back here, I had some family living in Hawaii, and they were paying like $6 or $7 a gallon of milk. Crazy. Alabama, Hope Dreams, what's up? Most isolated place on Earth, Pacific Ocean. There you go. Okay, cool. I'm glad you've seen it. Moderators, I am starting a Telegram room for you guys. Okay? So I need any moderators listening to me, please send me, just email me so I can send you a link to the Telegram room so all the moderators can talk. Okay? It really does help, especially when we're live. We do it over on in Marfugal, and if we've got issues in the chat, we can talk to each other, without having to talk to each other in the chat. It makes us be able to handle things a little bit more smoothly. Hey, Daniel, back here, brother. Good to see you. I am. I'm doing okay today. Hope you're doing good, brother. But yeah, guys, that's pretty much all I got right now. And again, I'll give you one more little rundown here. We had a long duration X 4.5 flare. Okay. This is something I didn't really talk about a whole lot here. We're already seeing an uptick in proton flux, guys. So we're probably going to get to a radiation storm. But remember what I've been telling everybody. In S1 radiation storm, we're not going to have any clue that that's actually going on. They will tell you that because I can show it to you. Where's the space weather scales? Right here. Solar radiation storm, S1. Biological effects, none. Satellite operations, none. Okay, so it's only going to have minor impacts on high frequency radio in the polar regions. Okay, way up next to the poles. So just like Kathy said, it's pretty isolated up there. There's not a whole lot of people up there, so it's not going to affect a whole lot of people. But as you start going up in the radiation storms, obviously, if you get to an S4, unavoidable radiation hazards to astronauts. They're still not saying here on the surface. So it's going to take something bigger than that to even affect us down here. And that's what I want to point out. Now, radiation storms of that size will typically last 3 or 4 days. So it's not like a CME that kind of hits and then kind of gets swooped out. Radiation gets here and it hangs around. And some of that's because of those rings I was just talking to you guys about. It gets stuck in those rings, and we have to, we actually need a hit from the sun at that point, geomagnetically, to help flush out some of that stuff. We see that often. Let me take you guys, I do want to show you guys this eruption one more time. Okay? So this is a very, very fast mover. It's not like a day mover here, but it would be here, in my opinion, in probably 2 days. Maybe a little more or a little less. That's a good question, Art. I would imagine it could. That is one of the best questions I've seen in a long time, bud. I'm not kidding you. I don't know if I've even thought about that. Wow. As much as I do this, guys, I learn more from you guys than... Oh, my God. What a question. I'm going to read it to you as soon as I post it here. Okay? I mean, wow. What a question, man. I wonder if a CME or a solar flare could change the course of an asteroid. I would have to say, yeah, it could. Depending. It would take some conditions, but I think that it probably could. Because it's mass. It's highly charged particles. The particles have mass. That mass can actually slow down our satellites. So I wouldn't see any reason why it couldn't slow down or change the trajectory of an asteroid that was coming in. Now, I don't know if the timing of it would have to be as such that it would have to really be able to hit it really hard to really change it significantly, I would think. But I'd never really even thought about that. It gives me something to think about, man. Thanks, man. It's good question. Good question. I've never... Daniel, yeah, exactly. I know Daniel's going to think about that one. That's a good question. Yeah, it is, Ivy. It's a big one. Hey, John, good to see you, bud. I mean, that's crazy, man. Yeah. So, yeah. You got my mind rocked there a little bit, man. I'm going to have to think about that for a minute. Wow, I never really thought about that. You know, well, we just had they just put that solar cell up there, right? We were talking about that. They were catching it. You know, people were seeing it in their telescopes and things. It was showing up like at a red line or something going across the sky. So if a solar sail could do something like that, and they're using that so they could, you know, maybe put it on an asteroid, I guess, and like change the trajectory that way of it. Um, I don't know exactly what the use of it is, but if that could do that, sure the heck the blast from the sun could do it. You know, wow. And if it's big enough, guys, I mean, come on, we know that a comet and even asteroids, if it has any kind of magnetic signatures, when it gets close to the sun, it will instigate a CME. Now, because of its proximity to the sun, it won't do it till it gets real close. So I mean, it's not going to help us unless it's coming from the opposite side of the sun, heading our direction. It's going to pass the sun before it gets here. But most of the time, the sun will eat all that up. Solar wind, and so you know, thinking about that more, Art. Yeah, solar wind definitely has an effect because it'll destroy a comet like really really quick. Now, a comet is made up typically of like, you know, ice and things like that. But an asteroid's a rock, so it's probably a little bit different. Yeah, 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 Rip, you're 100% right there, brother. Good point. Good point. Good point. Didn't get the notification? That sucks. Yeah, they can, John. Yes, they can. You're right. 100% they can. I'm sitting here talking to you like everybody else can see your comment. You know what I mean? I do that all the time. I'm sorry, guys. Here. Oh, he's talking about chakras? Okay. Let me put your solar storms. John enjoys them, he says. I'm trying to find the one I was replying to there. But yeah, they can make us sleepy. They can make us sleepy. They can give us headaches. Guys, the sun is the single most influential thing in your life, and you probably don't even know it. It affects everything around you and your environment. It affects us biologically all day, every day. The sun is one of the things that can affect the human resonance. When it shoots stuff like this at us, it will affect the human resonance. The radio frequencies bouncing around in between the surface and our ionosphere are very, very important to our biological wellness. That's why there's something called space sickness. If they don't pump 7.83 hertz into the space station, those astronauts that got stuck up there would go crazy. They literally would go crazy. And also people that work underground, same thing. Okay? They didn't just have the birds there, you know, looking for the birds to die during gas, like a gas attack or something that was coming out of the mountain. They used those to make sure that they didn't go nuts too. They really did. If you go back and research it, they knew about the human resonance when they didn't know about the human resonance. They just knew if they saw the bird getting a little crazy that they might want to get out of there. So, yeah, there you have it. Pretty smart, if you ask me. I mean, honestly, they might not have completely understood what was causing it, but they knew better. They knew enough to put a bird down there to, you know, whether either it's going to pass away from some sort of poisonous gas, or if it just starts acting just like it's crazy. And they would pull their whole crews out of there. It's kind of, you know, it was a good thing back then. Now we got instruments where we can detect it and stuff, but, you know. So if you're ever stuck in a coal mine, you know, go find you a bird. I'm just kidding. Yeah. Anyway, so there you go, guys. I am going to go ahead and pop off. If anything else happens, I will be right back here letting you know. You guys know I will. I was going to wait till later on tonight to do this live stream because I typically stream later, you know. But because of this, I wanted to come on. Other people are reporting on this now, too, I've seen. So go watch them also. They may have a different opinion, and maybe they have a better opinion. I don't know. I mean, so go watch everybody talking about this. I highly encourage you to do so. I don't care if you think I like them or not. Go watch them. Just leave out all the nastiness that sometimes that they spew, and just listen for the information. Again, yeah. If Dr. Tamitha Scove does a video on this, I haven't seen her post anything on this yet. I highly encourage you guys to watch what she has to say. Okay, I'm waiting for her to post something on this one, just to see what her opinion is on this. She is a space weather physicist. She it's basically free college when you go to her channel, guys, and she explains it to you in a way that you don't have to worry about the word salad, because if she has to speak word salad, she's like me. I will speak the word salad and then I'll explain to you what that word is. Because I just think it's kind of crazy when people get out here and start talking all big and bad, throwing all these big words around, thinking everybody's going to understand what they're saying. And all they're doing is hurting their own cause, because people will quit listening. And it just doesn't go anywhere. So, anyway, sorry for being a little hyped up here today. That comment had me going first thing this morning when I seen that. But, you know, and no harm, no foul. Please do not go give that person any kind of whatever over there. That is not my intent. I'm not even going to say the name. The comment, I'm not sure if I took it down or not. Maybe I will after saying this. I just want them to have a chance to see it before I pull it. And so I'll probably go ahead and delete that one. But just know, guys, I'm human. And when people talk a little crazy to me, every once in a while, I'm going to respond. I'll respond respectfully, but I will respond. So don't take my quietness for weakness. It's not what it is. I can promise you right now, it takes a heck of a bigger man or woman to keep their mouth shut than it does just to blow off at somebody. Because it's hard for me to keep my mouth shut sometimes. And because I do that and I choose to do that, I'm able to talk to everybody, right? And that's the whole point of this. That's why I don't understand people that do the opposite. So, anyway, look for Dr. Tamitha Scove's video if she does one. I would imagine she'll do one in the next day or so. If you don't know who she is, she's in my awesome channel list. She's in my subscription list. Go check her out. And thank you again, Gary, for this. Okay, we're going to end on this one right here because this is just awesome. God bless. Yahusha saves. And as always, you can drink this Kool-Aid.